What do we have today? We have prove that the derivative of inverse cosine of x is equal to negative 1 over the square root of 1 minus x squared, and x is between negative 1 and 1. So we're going to have to show that this is the case with the derivative of cosine inverse of x. So let's go ahead and do that. So first of all, we know, what do we know? We know that cosine, the cosine function, we know cosine, just whatever, just a general function, cosine of x, is continuous and differentiable. I'm just gonna abbreviate it, continuous and differentiable. Right, because we know the cosine function, it looks like, like kind of like a wave. I'm not going to go too much into that. You guys should already know what a cosine function looks like. And you can see that it is actually continuous because you can draw it with a straight line. And it's differentiable. You can take the derivative of it, right? So we know that it's continuous and differentiable. So given that it's continuous and differentiable, when you basically restrict the domain of cosine, we're not really going to go into too much restriction of the domain, but when you restrict the domain, we are going to get a one-to-one function. So when the domain is restricted, cosine, let's see, the domain is restricted, cosine exists. I'm not going to write this down, but this one, cosine inverse, is also continuous and differentiable within its restricted domain. So, knowing that, let's go ahead and do this proof now, this little proof. So let's go ahead and let y equals cosine negative 1 of x, right? We're going to let y equals that. So if we let y equals that, taking the definition of inverse functions, this also implies that cosine of y is x, right? Cosine of y is x. And when we restrict cosine, we restrict it within the domains of 0 to pi. Oops, you couldn't see that. Okay, so we let that y is equal to inverse cosine x, right? And given the definition of inverse, we can also say that cosine y is equal to x. So it's just the inverse. Inverses of each other, these two will cancel each other out and just gives us x. So let's see. When we restrict the domain, we restrict it to 0 and pi. So let's go ahead and just draw a sketch of the unit circle. 0 is going to be right here, and pi is going to be right here. So these endpoints are included because they have brackets instead of, parentheses. So all of this is included, all of this is fair game. This is where we would restrict cosine of x if we want to find its inverse. We want to make it into a one-to-one function. So yeah, now that we basically defined it, let's go ahead and take the derivative of this little function with respect to x. So we have dy over dx of cosine y is equal to x. Let's go ahead and take the derivative with respect to x. So let's see. The derivative of cosine, this is going to be, we're going to use a chain rule. So we're going to use dy dx cosine y. Let's go ahead and use a chain rule. The derivative of cosine is negative sign, right? Negative sign. We put the u inside of the sign. Negative sign y. And the derivative of y with respect to x is dy dx. Right? So we just use the chain rule to differentiate cosine. We're going to get negative sign y. And the chain rule states to substitute. There was going to be a u here, but I'm going to assume you guys already know how to use a chain rule. So we're going to substitute the u with the y. We're going to put the y were to use that. If this doesn't make sense, just go ahead and refresh yourself on the chain rule. And then after that, we're going to take the derivative of y with respect to x, which is just going to be dy dx. So you multiply these two together. And the derivative of x with respect to x is just going to be 1, right? Now our goal here, let's write it down here. Let's write it here. Our goal here, so we have negative sine y dy dx is equal to 1. So our goal here, this is called implicit differentiation, by the way. All right, so our goal here is to leave this dy dx alone. And how do we do that? We divide negative sine y on both sides, negative sine y. So we're left with dy dx is equal to negative 1 over sine of y. That's what we're left with, right? So now let's go ahead and define a little bit more things. So we have sine of y. Sine of y is going to be greater than or equal to 0. Do you know why? Because y is going to be between 0 and pi, right? Y is going to be greater than or equal to 0, and then less than or equal to pi. Because look here, this is going to be our y value, and it's restricted by this domain. Therefore, it's going to be positive. Our y is going to be a positive number. So knowing this, taking the information that we have here, we have this trig identity. Cosine squared y plus sine squared y is equal to 1. We're going to use this trig identity to find out what sine y is. So what is sine y? Let's solve for sine y, right? Let's solve for sine y. Let's go ahead and subtract cosine 2y from both sides. Cosine 2y is sine 2y is equal to, we're going to have a positive. Not yet, sorry about that. Ignore that. 1 minus cosine 2y. Now we're going to have to take the square root. And now it's going to be positive. Yeah, that's what I was going to write down. So sine y is equal to the square root of 1 minus cosine squared y. So let's go ahead and replace the sine y right here with this. So now we're left with dy dx is equal to negative 1 over the square root of 1 minus cosine 2y. 1 minus cosine 2y, right? And what did we say cosine was equal to? Knowing this inverse of this, where we know cosine of y is equal to x, right? So that's what we initially said. So since cosine y is equal to x, this tells us that dy dx is equal to negative 1 over the square root of 1 minus x squared, correct? Look what we have here, and look what we have there. We basically kind of proven this identity. So therefore the derivative of cosine inverse of x is equal to negative 1 over the square root of 1 minus x squared, for x is between negative 1 and 1. So we have proved this identity. So yeah, that's pretty much how you do this, and that is it.